Hi, this is a discussion of how to do a simulation, how to put together a simulation and how to use it in KEMCAD. We're going to start with a very simple simulation, which is a simulation of distillation, and talk about how to build that. And then we will actually do it in KEMCAD. So I'm going to show you the screens we're going to use and give you some explanation, and then I will do a KEMCAD demonstration doing that dynamically so you can see how the program works. But I thought it would be useful first to just show where we're going in this discussion. What we're going to do is go through the steps that you will have to use to start a simulation in KEMCAD. So the first thing we would like you to do is to open a file, name the file, and I'll show you exactly where that would be done on the screen, but name the file. The next thing to do is to check your engineering units and decide which set you want. You can have English, you can have metric, you can do a combination if you need to do that for your problem, but you do need to select the engineering units that are going to be used during the problem. You can always go back and change them, but it's important to try to get close. Step number 3 is to get your set of chemical components in KEMCAD. So you'll have to go through the list they have and select them and get them into the simulation. It does not retain everything for all components. It's got about 1,400 components in its data set. Step number 4 is to figure out what thermodynamics package you would like to use for your particular problem. It could be K values, it could be enthalpy options, but you're going to have to pick 2 things. You're going to have to pick how you're going to compute the thermodynamics equilibrium, either activity coefficient or K value, and you will have to pick how you're going to describe the enthalpy of the system. The next thing you'll do is draw the flow sheet with the unit operations in it and the streams. You'll define the feed, any product streams that you have, and define what those streams will have in terms of temperature, pressure, and composition. Then you need to specify the unit operations. You'll run the simulation after everything is done, review and plot results. Okay, so the first thing we're going to do is launch KEMCAD. And so what I suggest you do is, as soon as you're starting a new file, you save this file with the name and the location. There's a default folder that you might use, which are My Simulations. The file extension for the problem is going to be .cc7 for KEMCAD 7. So that will appear automatically after you've put a name to it and decided where you're going to place it on your computer. So this is the opening screen that you should be seeing when you're building a simulation. You would click on there to start a new file. These are recently used files on the left. This is the workspace where you're going to be putting in the simulation. There are a series of notes and comments that will appear in this section. This will show you the simulations that are underway. There may be charts, there may be 2 or 3 simulations you're doing at the same time. You can see what's open. On the right-hand side is the palette for KEMCAD. It's got a bunch of systems in it that you can use, a feed stream, a product stream, and then a whole series of unit operations that you can include. Along the top, you can see the key steps that you were taking. The key steps, as we said, is you're gonna start over here and open a file. The next thing is under Format, you're going to set the engineering units. Under Thermophysical, you're going to choose the components, and you're also going to choose the thermophysical property choice. You can specify the unit ops here. This is the Run button. This button helps you report. This button helps you plot. This section helps you size the equipment. For example, distillation, it will size the trays and so forth and give you the flows. And then there's some other tools available here. There are also some duplicates here. For example, this button is the run button. So at any time, if you want to run your simulation, you click on this one. This button lets you select components. This one will let you select an activity program or thermodynamics program to use. Okay, I think we're ready we've got a brief introduction and we'll see how to use some of this stuff. So the first thing we're going to do is select engineering units for the problems. Here is the first screen that comes up. On the left, there are buttons here for English, Common SI, Formal SI, and Metric. You can click any of these, and it will give you the default settings. You notice that there are two things. There's the unit selection, so it's got time, mass, temperature, flow rates, column diameters, areas, so forth. And also options and references to what is, in this case, to what is this referencing? And an example is shown here. For example, the stream units are the total flow, usually, either mole or mass. Component flow is given either in mole and mass. The vapor reference temperature is 60 if the units are for Fahrenheit or Rankine. It's 0 if the temperature units are centigrade or Kelvin. Or you can do a custom. So if you have, for example, thermodynamic data that's got a different reference temperature, you can actually input it here. There's also an atmospheric pressure reference, which is taken to be 1.01325 bar. Okay, now let's select a component. So there's a little search engine in here which we can search by name, chemical abstract systems number, formula, or ChemCAD ID. When you put in a name, the search engine is going to find anything that's got your full name. So if, for example, you search for ethane, you're also going to get methane because it contains the last 6 letters. When you found the component you want, you're going to add it to the selection for the problem by clicking the right arrow, excuse me. So note that there are 3 places that you can go to choose components. You could have clicked the component icon over here under ChemCAD Explorer. You could click the thermophysical tab, or you could click this icon here, which is the same as that one, but appears in the workspace, just above the workspace. So there's a number of different ways to get to these, depending on what you're comfortable with. Okay, so you've selected components. Now we're going to select the thermodynamics that we use. And we're going to use either the thermodynamic wizard, which helps you, if you don't know anything about your system, helps you decide what to use. Or you can specify it to be whatever you want. Usually, for hydrocarbons, you'll choose an equation of state. If you have water in the system, you would often use activity coefficient models. If you have water plus hydrocarbons, which are going to be fairly non-ideal, you use UNIFAC. If you have water plus electrolytes, then you need an electrolyte model. Make sure when you do this, you include the temperature and pressure range of the problem. Usually this is not an issue, but sometimes it is, because there are limits to the temperature and pressure ranges for which the thermodynamic models apply. We have a couple questions that we need to ask ourselves in this section. Do you have 1 or 2 liquid phases? If you have 2 liquid phases, you better make sure you have a model that will compute that. You may need a global K-value model, which would give you global values for a bunch of different components. There's also a separate enthalpy model that you can choose if you want. You also need to check transport properties to verify that these are appropriate for your materials and your conditions. Once you have selected the thermodynamic settings, a message is going to appear which says all streams should be reinitialized. Proceeds with reinitialization? Click yes. For example, let's suppose you've run your problem and you're using the NRTL method for the thermodynamics, and you decide, after you've made some runs, let's go to the Wilson. You can go to the Thermodynamics tab, click on the Wilson, ask for it to be selected. When you are ready to run, before you hit the run button, it will ask you, are you ready to change the thermodynamics section? It will reinitialize the problem. Basically what it does is does flashes with the new thermodynamics on all the streams going into or out of the process as a way to start. That lets it start on a basis for which it can find a solution usually. Now that we've chosen thermodynamics, we've gotten our components, we've got our unit selected, we're ready to draw the flow sheet. In general, you should have a template or a sketch of the flow sheet that you're going to follow. It's usually best to put in unit operations in the order in which they're going to appear in the process. It makes the flow sheet and the reports easier to read, and it also gives you a stream naming convention starting with 1 on the left-hand side going to 25 or whatever the final number is on the right-hand side. We're going to pick off unit operations from the palette and put them on the screen. And so sometimes you will find that you can't turn the palette plane on or it's stuck. If this happens, and it happens perhaps without you knowing it, click View, go to Palette, make sure that it's unpinned and change that. Okay. What you're going to do to draw the flow sheet is you're going to find the icon you want, like the feed arrow. You're going to click on it and move it to the workspace. When it's on the workspace, you can move it, you can duplicate it, you can resize it, you can flip it, rotate, or delete it. But you have to get it on the workspace first. Each unit operation has an ID in an oval associated with it, usually on the upper left-hand corner. The streams have IDs in rectangular boxes, which appear on the stream line, and both the streams and the unit ops are numbered in the order in which they're created. The feed and the product arrows show the starting and end points of the feed. When you start connecting these things up, you will connect a red dot to a blue dot. You're going to go from red to blue all the time. So when we connect a unit operation with a stream, we'll find a red dot on the unit ops. We'll connect it to a stream to a blue section. When you're defining the streams, you're going to define the composition, the temperature, and the pressure. To do that, you can right-click on the streamline and select Edit Stream, or under Specifications, you can click on Feed Streams, and you will automatically be sent to the feed streams. When you specify a stream, you have a limited number of variables. You can specify 2 of the 3 of temperature, pressure, and vapor fraction. Once you've specified 2, ChemCAD will automatically estimate the 3rd and compute the stream enthalpy. Of course, to do this, you also have to put the compositions in. If you click Flash, you will find that you will get a computation. You'd like to do this early and often to make sure you haven't under or over specified a stream. When you're looking at equipment, you will right-click on the unit op. You will select Edit Unit Op Data. Any green text labels are required entries. All the other entries are optional, and usually you should fill in only the required entries. Otherwise, you're not sure what's being computed and on what the basis you are going to do your calculation. Finally, you're ready now to run the simulation. You've put in all the information. You've got all the unit ops connected. You've got streams specified. You have specifications done for equipment, and you're ready to hit run. It will compute if there's a warning. It will not compute if there's an error. You will have to fix errors before you will get a run. And that's a summary then of putting together a simulation. We will now do a live exercise in which we will build a simulation from scratch so you can see it. But I think this little description will help you understand what needs to be done. Remember, you need to do all those items. Usually it's best to do them in order so you don't leave anything out. So you're ready now to go to KEMCAD.